Okay, welcome to Inverse Functions Part 1. All I'm going to talk about in this video is what it means to be a one-to-one function and at least give you an overview of three methods to actually tell whether or not a function is one-to-one. So real quick, let's just talk about what it means to be a one-to-one function. We know that if you're a function, each of your inputs maps to only one output. And that's all well and good. If it works both directions, if each input maps to only one output and each output maps to only one input, then you're not only a function, but you're a one-to-one function. So now these are a subset of the set of functions. And remember, functions are a subset of the set of relations. Okay? So how can we tell if a function's one-to-one? Probably the easiest way to tell is if you have the graph. And if you have a graph of a function, which we'll just make a quick graph over here, the nice parabola, and just like the vertical line test would tell you that it's definitely a function, if it passes the horizontal line test, then it's one-to-one. This one is not one-to-one because it fails the horizontal line test. There are places where it crosses the parabola in more than one place. So this is not. Okay. Another kind of function, we'll just draw one. Something like this. We can look at that and we can see that yes, it's a function. It passes the vertical line test. And yes, it's also a one-to-one function because it also passes the horizontal line test. So yes. Okay. And that's pretty cool. If you know that a function, or if you know the graph of the function, then it's pretty easy. You just do that horizontal line test. If it's already passed the vertical line test, and you can tell immediately that it's one-to-one. Okay? So what if you don't have the graph and you still want to figure out if something is one-to-one? Well, there's a couple different methods. And I'll try to quickly go through each of those. One is what I call, and let's just do two methods. One is find a counterexample. In mathematics, something's true only if it's true 100% of the time. So if we can just find one example of where it's not true, then just not there. It's not true at all. Okay, we can't say that it's true if there's a counterexample. So a good example is if you say that no mammals fly, right? And that would be false because you say, well, there's bats and bats fly and they're a mammal, right? Or no mammals swim in the ocean, and you'd say, well, that's false because look at the dolphin, look at the whale. So if you can find a counterexample, then it makes that statement false, and it doesn't matter how true it is in other contexts. So find a counterexample. So let's take a function, f of x squared minus 2x. And we want to know, well, is this a one-to-one function or not? Well, we can factor this. We're going to change this to a y. And we're going to quickly realize that now I'm looking at, are there two different ways to get the same y value? And if there's two different ways to get the same y value, then all bets are off. Well, we suddenly know this already. We know that the zeros for y, right, are going to be when x is 0 or 2, right? So if we turn this around, right, and the x became the output and the y became the input, we'd say that we had one y value that maps to two different x values. And so that tells us right there we found a counterexample that says, look, if I flip the x and the y, that's not going to be a function because I would have one input that maps to two different outputs. So this is the counterexample method. This is not one-to-one. Okay, there's another way, and it's a little more rigorous. I guess you could say I maybe like it better. But it works something like this. And I'm just going to call it the A equals B method. Okay? So what you do is you have a function, and let's just use something fairly simple, like, and you want to know, is this a one-to-one function? And so what you do is you put A in, and you get 1 over A. And then you put B into the function, and you get 1 over B. And then you set those two functions equal to each other. And if you can prove by, doing some mathematical calculations that in the end, A is equal to B, then it is 1-to-1. Okay? I think it's easy to see if you just take the inverse of both sides that A has to be equal to B for that to be equal. So without doing the mathematics, basically give you an overview of the methodology. So there you have it. That is 3 different ways to consider whether a function is not just a function, but a one-to-one function. And the nice thing about one-to-one functions is when you calculate their inverse is also a function. Okay? So when you take the inverse of a one-to-one function, its inverse is also a function.